Hello, advanced algebra students, and welcome back to another video lesson as we continue the exploration of solving different types of quadratic equations, including absolute value and quadratic. And so Friday, we spent some time talking about how to solve the absolute value functions, whereas today's video is going to focus more on solving the quadratics, or the squared components. And we started chapter 6 earlier in the semester, and we went through some solving and factoring and graphing, and then we jumped over more to some different components with trigonometry, and now we're kind of coming back to more solving. And so I want to make sure that we review a couple key features first of taking square roots, or what are called radicals. The square root of 9 doesn't necessarily only have one answer. We hopefully now know that it has two. It could be 3, or it could be -3. So let's say it has two answers. All right, 3 times 3 was 9, -3 times -3 was 9. In this one, where they put the negative sign out front, they really only want the opposite. So they really only want -3 here. Right, they're only looking for the -1, which is why they put that out front. And if there's a negative underneath the square root, there is no answer in the real numbers. So we say no solutions. Very soon, though, we are going to learn about what's called imaginary numbers and how this does have what's called a complex imaginary number. So we'll get there. But for right now, the square root of anything negative, if it's underneath, is nothing, because I can't take 3 times -3. That's not the exact same value. Now, a very similar process applies for what we did the other day, this absolute value of 9. Well, the answer was 9 or -9, right? We could have 9 or -9 if I had the absolute value of, I should change that, the absolute value of x equals 9. We have those two answers, 9 or -9. Now, if I say the opposite of the absolute value of x equals 9, they only want the negative. And if I ever say the absolute value of x equals a negative number, that is no solutions, because we can't get the distance of something to be negative. I can't find an absolute value of something and it's going to equal a negative value, because that distance, as we described, was always positive. Now, how does that play into what we are doing? Well, as we solve these different quadratics, we're going to end up taking a lot of square roots. The square root of x squared is how I get x by itself, right? Or typically we just write it as x equals, but we should be looking at the absolute value of x squared. And then we take the square root of the other side of 100. And so what we can do is graph them. I can say y equals this part, y equals the 100, graph them both in Desmos and figure out what x values do I get that are solutions. And so typically, when we take the square root of x squared, we're going to say that the absolute value of x equals whatever the square of that positive number is, but we normally will just jump to this bottom step. Now, pulling all of this information together shows us that we really have 4 different ways of solving a problem that looks like this. X squared minus 9 is 0. We could use that quadratic formula. The opposite of b plus or minus the square root of all of that information all over 2ac. Now, we could. Not very effective, but we could. We could certainly factor this and show that x plus 3 times x minus 3 are the two factors. And then, again, a little bit more steps maybe in that one, but it would work. Graphing, you could definitely go and graph y equals x squared minus 9 and find the zeros, or we could add 9 to both sides and then take the square root, which is where we are primarily focusing today. So let's look at these two and try to solve these two. Let's just focus on number 1 over here. What would be the first step? hopefully. Again, just like we had with the absolute values, we need to isolate the x squared part. I can't touch and do anything with this until the other information is on the other side. So I'm going to add 12 to both sides, and I'm left with 2x squared on the left side equals positive 12 on the right. That means we need to divide by 2, and if I divide by 2 to both sides, I'm left with x squared equals 6. Now that I've got x squared isolated, we can certainly take the square root, and really that means the absolute value of x would have to equal the square root of 6, which means x equals plus or minus, right? We need a positive or negative for absolute value of the square root of 6, and we leave it as that square root of 6 because that's the exact answer. That's exact, right? We haven't learned how to simplify those yet, so we'll leave it as plus or minus the square root of 6. In number 2, we already have x squared by itself, so the first step is to take the square root, or x, the absolute value of x equals, well, wait a second. Can I take the square root of a negative number? That's impossible at this point. We're going to learn something soon on how to do that. But for right now, we are going to say that that is no solution because we can't physically do that problem. So those are some of the similar things you're going to see in today's practice, some of the things that you got to be prepared for. But what I want to focus on is how does this look differently if I'm trying to solve the absolute value function versus a quadratic function? It's a very similar process. We have to isolate, as we learned on Friday, we got to isolate the absolute value part. And so I would subtract 2, leaving me with the absolute value of x minus 3 equals 8. And now that we've isolated that, we can say what's inside has to equal the positive 8, or it has to equal the negative 8. Right? Remember, if I had just absolute value of y equals 8, we get those two answers. And so we branch it off twice, and we solve each one by adding 3. We could say x equals 11. Or if I add 3 to the other side, x equals negative 5. So that's the absolute value solutions. But let's see how that might compare to the square root, or to the squared quadratics. Same type of setup. I can't touch anything here. Let me put something around that until I get rid of the 2. So we subtract 2. X minus 3 quantity squared equals 64. And now we can take the square root of both sides. In doing so, remember that this is 8 or it's negative 8. And so we need to take what was left inside that parenthesis and set it equal to both. X minus 3 is 8, or that x minus 3 could equal negative. X minus 3 could equal the negative 8. And we're going to solve both of those to come up with our x values. And therefore, we're going to add 3 to get x equals 11. When I add the 3 over here, we get x equals negative 5. So we got the same results, but notice how the two original equations weren't necessarily the same. We had absolute value plus 2 is 10, and then that squared plus 2 is 66. So a lot of the same processes, I think, if you understand that, where we have to isolate either the absolute value or the parentheses, and then we can solve them twice. So let's take a look at just a few more maybe different types of examples here. I'm on page 2 of the 6B packet. Simplify the opposite of the square root of 64. Remember, whenever they have that out there, they only want the negative answer. The square root of 64. Typically, we're just going to say that it's positive 8, but right now, because we're not solving, we leave it as positive 8. We're in letter C, where it's solving x equals, it's because of this that we say x equals positive or negative 9 when we're solving. So a slight difference in those two. Whereas letter D, if we're ever asked again to take the square root of a negative, this is no solution. If we jump down to number 5, where we are trying to solve, this is where we are taking the square root of both sides, which yields x equals plus or minus 9, because the square root of 81 is 9. Or if we take the square root of 200, we're just going to say that x equals the plus or minus square root of 200. Same thing here, x equals the plus or minus square root of 31. When we take the square root on letter D, we end up trying to take the square root of negative 49, which again means no solutions. So those ones are all what I would call one-step straightforward solving. I want to take a look at D and E on the next page, and I want to encourage you to pause the video right here to try and solve both of those on your own. Okay, in letter D, again, we need to isolate the x squared, and the first thing to do is to add the 10 to both sides, meaning 5x squared equals 50. Our next step, we need to get rid of the 5 by dividing, meaning x squared is 10. Now that we've isolated the x squared, we can certainly take the square root. I don't know the square root of 10, so I'm just going to leave it as that radical and put a plus minus sign out front to say x equals plus or minus the square root of 10. Now, letter E might be a little bit trickier. Our first step here is actually to get rid of the dividing by 5. So we will multiply both sides by 5. Can't really touch anything up here in the top until I got rid of that 5. Since that's division, the opposite is to multiply. We have 2x squared minus 7 remaining on the left, and 13 times 5 on the right is 65. Now we need to add 7 to both sides, and we have 2x squared equals 72. When I divide by 2, I have x squared is 36. And now that I've got the x squared component isolated, we can take the square root of both sides and say that x equals plus or minus 6. So a few steps in that one, but again, we're trying to isolate the x squared part so that we can eventually take the square root of both sides. I hope you wrote some of these examples down, and that if you have any questions, you will indeed please reach out. Otherwise, until next time, everyone, stay safe.